Hello and welcome to another video. This is cracking the Cryptic app Foggle 4 pack puzzle number 31, Blurry Black and White. The rules are Foggle 4. Correctly placed digits clear the fog around them. Classic. Every row, column, and box must have all numbers from 1 to 9 exactly once. Partial Kropki. A white dot between two cells indicates that the neighboring digits are consecutive. A black dot between two cells indicates that one of the digits is twice as big as the other digit. Not all possible dots are given. Let's begin. We are given a vision of two black Kropki pairs, and we know that these cells cannot contain numbers 5, 7, and 9 because nothing doubles into these values and the double of their value is over 9. So this is 1, 2, 3, 4, 6, or an 8. Now, let's just quickly select every other possible square in this grid and fill it with every value that it could possibly take. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And we immediately notice one thing here in this central box. Namely, we have 1, 2, 3, 4 pairs of consecutive values. So the only way you can have 4 non-repeating pairs of consecutive values, because they're all in one box, is if you have numbers from 1 to 8 or numbers from 2 to 9. So let's assume it's the first case. Let's assume that it's numbers from 1 to 8. In that case, somewhere, arbitrarily, let's just start here without loss of generality. You would have 1, 2, 3, 4, 5, 6, 7, 8. But no matter how you place these 8 digits, if you start from 1 and end with the 8, number 9 would have to go in the center. And that does not work. So it cannot be that case. It must be the other case where you have numbers from 2 to 9 around the grid. So this is 2, 3, 4, 5, 6, 7, 8, 9, and now the number 1 has to be in the center. Obviously, we don't know the placement from numbers 2 to 9, but they are somewhere here. And in fact, this must be the number 2 because these two are a black Kropki pair. These two are consecutive, so this is the 3. And then this must be the 6 because they're a black Kropki pair. Now, that reveals some new stuff, namely that these are black Kropki pairs, so they cannot contain 5, 7, or a 9. And because the 6 is here, number 3 cannot be within this black Kropki pair. So let's just select every other square in this box and every square in this column and remove 4 and 8 because they are a pair up here. Now, this cannot be the number 1, obviously, because they're consecutive. Cannot be the number 9, because number 8 cannot go here. And cannot be a 2 either. We asked the question, can this be an 8? Well, if that was an 8, then this would have to be the 7, and now there is no 6 here to be consecutive with the 7. So this cannot be an 8. It must be the number 4, making this the number 8. Now this cannot be a 7 because it's consecutive to the 4. And it also cannot be a 5 because if it was a 5, this cannot be a 4 again, it's taken, and it cannot be a 6 either. So no value here would be consecutive with the 5. It must therefore be the 3, meaning that this is the number 2. Now these two are a black Kropki pair, so this cannot be a 5, a 7, or a 9, leaving us with a number 1 here, and a double of its value is 2, and since they're consecutive, this is the number 3. We cannot have 5, 7, or a 9 here, because it's a black Kropki pair, and 6 cannot be here, because 3 is taken, and number 1 cannot be anywhere, because 2 is taken. So that's an 8, and then this is a 4. The only digit consecutive with it in these possible candidates is the number 5. Now, this cannot be a 1. It can be either 4 or 6, but it cannot be 7, 8, or a 9. Over here, it cannot be the number 1, right? Or a number 9, or an 8. It cannot be a 4 either, because if this was a 4, then this would be a 6, and 4 and 6 are consecutive. And it cannot be a 6 for the same reason, because it will force this to be a 4. And they're not consecutive, so it can only be a 7, meaning that this is a 6, and so this is the 8. Now, a number 1 must be somewhere down here, meaning that it is nowhere else in that same row. And now we should take a closer look at these cells here. Namely, we notice one thing, because number 1 is in center and we have a 2 free pair, the rest of the pairs, we have 3 more pairs of consecutive values. They must be the 4-5 pair, 6-7 pair, and an 8-9 pair. And number 6 cannot be here to give us the 6-7 pair. So a 7 cannot be here. And if you take a closer look at this, it's the same thing. Number 6 can be neither here nor here. And that is why this cannot be a... so basically, neither 6 nor 7 can be here, meaning that this cannot be a 6-7 pair. And the only place left for the 6-7 pair is down here, so that is, in fact, the 6-7 pair. This cannot be a 5, 9, 4, or an 8. And that's why you don't have a 6 or a 7 anywhere else. All right. Now, that gives us something quite interesting. These digits are pretty close together, so let's assume that this is a 2-4 pair. In that case, you would not have a 2 or a 4 anywhere, giving you a 9 here, but this is a 5-9 pair, which is in fact a contradiction. So this cannot be the 2-4, it must therefore be the 3-6 pair. And that's why you don't have a 3 or a 6 anywhere in that box or row. All right, so this can be 4-5, this can be 8-9, or the other way around. Okay, but this cannot be a 9 because this cannot be an 8. So this cannot be a 9. And this cannot be a 4 because this cannot be a 5. And over here, this cannot be a 9 because this cannot be an 8. All right. Now, 5, 7, 9. So this is either a 5, 4 or 4, 5, right? Or it is a 9, 8. If it's a 4, 5, then 5 is somewhere here, leaving us with a 7, 9 up here. So 5, 7, 9 wouldn't be down here. And if it's an 8, 9, again, 9 wouldn't be here. So neither would 5 and 7 be down here. So in both cases, 5, 7, and 9 are not down here. Okay. So what else can we do? 1, 2, 3, 4, 5, 6, 7. So the only square left for the number 7 is here in this row. And that reveals some new stuff, namely that these two digits are consecutive. And that's why this cannot be the number 1 or a 9 or an 8. So that's a 4, meaning that this is the 3 and this is the 6. And that gives us an 8, 9. And therefore this is the 4, 5 pair. All right, so this is the number 2, this is a 4. And now we have, this is 5, this is the 4. This is a 1, 3, 9 triple, so you cannot have number 9 down here. And let's see what else we have. We have a triple black Kropki, so this cannot be 5, 7, or a 9. And furthermore, this cannot contain a 3 or a 6, because if this was 6, this would be a 3. Nothing could be here, right? So it's the same way the other way around, so it cannot contain a 3 or a 6 anywhere. This cannot contain the number 1 because you would need to have number 2 on both sides, and this cannot contain the number 8 because it would need to have 4 on both sides. Now, no matter how you slice it, if a number 2 is here, then it would be 1, 2, and 4. So 2 and 4 would be a part of this. And if a number 4 is here, then on one side you would have number 2, and you would have number 8 on the other side. So no matter what, 2 and 4 are a part of these 3 cells. So 2 and 4 cannot be anywhere else in that box. So now let's quickly just go through the digits and see if maybe something opened up. So yeah, 7, 9 is a pair here, meaning that this is a 5. So 1, 2, 3, 4. Okay, so 4 is either here or here, meaning that it cannot be up here. Therefore, this is the number 4. And that gives us our next digit that was just placed for us automatically, so we have to manually clear the nodes. You cannot have a 7 anywhere here. Oops, yeah. And now, therefore, this is the 9, this is a 6, this is a 5, this is a 7. Meaning that this must be the 7, and this is the 7. Now that reveals another black Kropki pair, which cannot have a 5 or a 9. And number 2 is taken, right? Because 2 is somewhere here. Actually, because, yeah, 2 is somewhere here. So this cannot be a 1. Now, since this cannot have the number 4 anywhere, this cannot be the 8. So this is a 3, 6. 6 and 3. Okay, so the number 3 must go up here in this box. And yeah, let's just go through the digits again. So number 1, number 2, 3, 4, 5, 6. 6 must go up here. 7, 8, and lastly, do we have a 9 placed anywhere? We actually don't. Oh, 9 is here. Okay. That gives us another black Kropki pair, which can have 5, 7, or a 9. And this cannot be the number 4, actually, because neither 8 nor 2 can be here in this row. So this cannot be a 4, so it's a 6, 3, meaning that this is 7, 6. So this is 7, 3. And therefore this is number 1, 9, 7, 3. Okay. So 2, 8, 5, 2, 8, 5, 2, 8, 5, that's a triple, so you cannot have 5 anywhere here, giving us a 4 and a 6. 5 is here, and so 4 is here, which gives us a number 2 here. So this is the 1, and then this is the number 4. 8 is here, 2 down here, and this is the number 1, 5, 8, 2. 1, 9, 1, 9 is a pair, meaning that this must be the number 5. And the 8 is here. 9 is down here, giving us a 1, 9. And then this is 1, 9 again. 1, 1, and 9. This is 8, 2, 9. 5, 2, and finally 8 and 5, and we are done. That was a pretty quick puzzle. Hope you guys enjoyed the video, and see you in the next one.